Hi everyone, welcome to the Electromark ANSI training webinar. My name is Courtney Achi and I am the marketing specialist for Electromark. Before Brandon introduces himself, I'm going to address a quick housekeeping item before we get started. So if you have a question at any point during the webinar, please use the GoTo dashboard to type in your question. At the end of the webinar, I will read your question aloud for Brandon to answer. Now, without further ado, Brandon Furber.
Yes, so thank you, Courtney, and welcome everyone to Electromark's Z535 training webinar. I'm Brandon Furber. I'm Electromark's application engineer, and I've been with the company for 13 years. I have extensive knowledge of our materials, products, and manufacturing process capabilities. So my role is a hybrid role that's intended to work with our manufacturing group as well as our internal and external sales and marketing groups to advise towards and find the best solutions for our customers' safety marking and asset ID requirements. For those who attended any of our previous materials webinars, this is the 6th in a series of several that we've been presenting over the past 12 months, each one covering a different category of materials or applications. We're going to follow an agenda today that covers ANSI Z530 background, the reasons we need to comply with it, 5 key design areas of the standard, and then frequently asked questions, and then finally at the end we'll finish with questions from the audience here today, so be sure to jot those down as we go through the presentation so you can ask them at the end. But before we go further, throughout this presentation you may hear me use the shorthand reference for ANSI Z535, so I may just say ANSI, I may say Z535, or I may just refer to it today as the standard, but all of those references you can take today to mean the ANSI Z535 standard. So let's go into background. What is ANSI Z535? It's an American standard that sets forth a system for presenting safety and accident prevention information. The standard is revised every 4 to 5 years. The most recent revision that we're working from now is 2011. The next revision is dated 2016, although obviously here we are into 2017. So to clarify that, in January I spoke with the senior program manager that's in charge of the revisions for the Z535 standard, and I was given sometime in March as the month that it would have been published for sale, although to my knowledge it's not yet been published. In that discussion, however, the senior program manager for the standard verbally informed me that although there are a few minor changes regarding color specifications, I was informed that all the other sections of the standard were going to be reaffirmations of the 2011 revision we're working from now anyway. And then finally, Z535 is developed under NEMA, the National Electrical Manufacturers Association, by committees of voluntary industry experts. It's published by NEMA and it's accepted and distributed as an approved standard under ANSI. And so I mentioned that it's developed by committees of voluntary industry experts. What kind of people or industry experts serve on these committees? So they come from major equipment manufacturers and engineers, industry-sponsored safety and technology associations, privately operated safety and technology consulting firms, electrical utility engineers, insurance companies, and even public and private lawyers and legal experts. In fact, it's kind of interesting to know that back in the 1980s and 1990s, the former owner of Electromark served on one of these committees through several revisions. Z535 is a graphic design guide that includes elements such as color, symbols, message content, layout format, and font. The standard attempts to not only promote hazard awareness by presenting a uniform graphic system, but also to increase the recognition effectiveness of the safety hazard message. The effectiveness of all the critical design elements are supported by empirical human factor testing, research, and/or the experience and logic of industry and safety experts. The standard contains nearly 300 pages of technical information divided into 6 sections. Some of those sections integral to others and some not really of primary relevance to the applications we have in the electrical utility industry. So I don't know who in our audience here today would typically keep a copy of the standard or keep up to date with the latest revisions. But the points on this slide certainly offer a challenge to anyone that's not already familiar with the standard, especially when trying to design your own safety signs from scratch. And then, of course, not to mention that the cost limitation is something that your own organization needs to justify. So this is one area where there's an advantage to using specialized sign label manufacturers such as Electromark. So for instance, it would be in our best interest, and we obviously do, we go out, we buy the most current revisions every time they're published. We go through them with a fine-tooth comb, and then all of our frontline customer service and art staff are also trained in the details of the standard. So before we get into specific design elements of the standard, I think we should revisit why we need to understand and design all of our safety signs, labels, and tags to the Z535 standard. Z535 is a voluntary standard that intrinsic of itself is not enforceable. And so essentially it's offered as industry best practice. And it provides little or none in the way of decision guidance for specific physical application use. And what I mean by physical application use would be, for instance, specific equipment, locations, work environments or tasks, etc., where safety hazard marking devices are required. So to give you an example, a specific area might be a fence substation equipment enclosure where a sign is required at each side and at each gate or entrance, but that kind of information is not provided by ANSI. Requirements like these are typically provided through relevant codes and regulations that are put forth by, for instance, OSHA or the NESC, just to name two. So conformance to the Z535 standard becomes mandatory, or what I would then call compliance, when it's incorporated by reference into the codes and regulations you have to stay in compliance with. Most codes and regulations in the U.S. don't try to reinvent the wheel by proposing their own design standards, but rather they incorporate all or part of Z535 wherever safety hazard markings are required. And the reason I show the map here is because it depicts states that adopt the NESC as their state code. And so the NESC, for instance, the latest revision of it requires that safety signs, labels, or tags utilize the Z535 2011 revision for their design. So in addition to providing a system of safety communication to keep our workers and public from harm, another of the reasons we need to comply with the standard is because, as we're all aware, we also live in a world of lawsuits. And lawyers are always going to find a way to try to shift liability to deep pockets in order to win awards for their clients. This, of course, extends to failure to provide adequate warning. And then finally, we need to avoid fines from jurisdictional authorities. So there are 5 key design areas which are covered under the 6 sections that ANSI Z535 is comprised of. To give you an idea of the depth, each section is approximately 40 to 60 pages. Sections 1 and 3 are not standalone, but rather are treated as specific and separate design elements that are relevant to all of the other more specific, application-specific sections, numbers 2, 4, 5, and 6. So we won't address those individually. We won't address Z535.4, which is product safety signs and labels, because one, they're intended more for safety warning and instruction for end users of products. For example, a consumer power implement might have a label on it that says caution pinch point. A lawnmower might have a label that says danger, do not attempt to clean debris from chute while engine's running, etc. And so obviously that's not really relevant to our industry. And then second, because other than the actual application, the design elements in product safety signs and labels are nearly identical to those for signs anyway. And as a matter of fact, the ANSI committees have even considered merging these sections in some future revision. And we won't address 535.6 product manuals instructions for similar reasons as above. While the same basic design elements are incorporated, the application for manuals instructions are mostly relevant to equipment manufacturers. So in the electrical utility industry, the sections we mostly deal with are environmental facility safety signs and safety tags and barricade tapes. And then finally, I want to make a clarification on the definition and use of the word sign versus label. So from a materials perspective, in the sign and label manufacturing world, we typically consider a label as anything that's a thin film with a sticky back. And then a sign obviously is a rigid material that's fastened in place by screws or bolts. But in the context of functional use application under Z535, safety labels are being used in a signage-like application, and so they would also fall under environmental and facility safety signs. So now let's get into what I consider the 5 key or primary design elements in the standard. And they're going to include color, header and signal word choice, type style, justification, and type size, message content, and pictogram symbols. The first is color. Z535.1 safety color is used by all the other sections of Z535. The standard establishes a benchmark of uniformity using a vivid primary color set of strong hues that minimize the possibility of critical confusion. These colors are not a specific point of color, but they're plotted within a measurable window of space or tolerance by a 3-coordinate system. But in order to provide a more tangible reference, the standard includes a closest Pantone number, which is not to be misinterpreted as the color specification itself. And so to let you know what I mean by that, if I were to give you 3 coordinates that define ANSI Safety Red, you're still going to scratch your head and say, what is ANSI Safety Red? But I can give you the closest Pantone number. You could look that up in a Pantone book or even on the computer, and then you could get an idea what that color looks like. But that's not the actual specification. The specification is a 3-coordinate system that's plotted in 3-dimensional space. And so here again, this slide depicts those windows of color with all of the colors, and they're shown plotted within their coordinate limits. So what's the significance of using a vivid primary color set of strong hues? As mentioned again, this eliminates color confusion, but it also minimizes metamerism. And so metamerism is the phenomenon where certain colors will look different under different light sources. And by minimizing that, the colors remain recognizable in variable spectral light conditions. And so the important takeaway from this discussion of color that I'd like you to have is that locally sourced or non-safety specialized sign label shops may not have the experience with the standard or even the ability to determine, measure, and match colors that correctly meet the specification. And additionally, most of the digital print technologies that are mostly accessible to smaller print shops lack the ability to produce the intense saturated colors that Z535 requires. So here again is another area where using a specialized sign label manufacturer that specializes in safety signage and understands the standard can be a real advantage. Let's talk about the design application of the colors that are used under the standard. The brighter, more vivid colors such as safety red, orange, yellow, and blue are utilized primarily in the signal word header panel at the top of the safety hazard sign. The standard allows the word message lettering to be black on a white background or white on a black background, depending on which color scheme is determined or considered to be more legible in a given application. Unfortunately, Z535 does not provide specific guidance towards which scheme would better suit certain applications. This is ultimately left to the posting utility to determine. So where does that leave you in terms of guidance? Well, Electromark believes that the text background scheme is generally most relevant to making the outline of the sign more conspicuous against the mounting surface. So white letters on a black background, we find, tend to visually blend together. And then the black outline especially begins to disappear in low light conditions or when it's framed against darker backgrounds. Therefore, Electromark's experience favors black text on a white background as being the most effective in outdoor environmental applications where shadow, light, visual patterns of various objects interact. Next, safety headers and signal word choice. Specific colors are always associated with specific header words, and only those colors with specific header words. So white lettering on a safety red background is used for danger. Black lettering on a safety orange background is used for warning. Black lettering on a safety yellow background is used for caution. And then italicized white lettering on a safety blue background is always used for notice. Danger, warning, and caution are hazard-related words where there's potential for personal physical injury. Danger is associated with a hazard that will result in death or serious injury, and it should be reserved for situations where the reader of the sign is in direct physical proximity of the actual hazard itself. And so that should be reserved for the most dangerous situations. Warning is slightly less elevated level of hazard, and it's associated with a hazard that could result in death or physical injury. And it should be used where there's a barrier of protection between the reader of the sign and the actual hazard, essentially indicating that you're safe where you are, but if you proceed further, you expose yourself to imminent danger. Caution is used for potentially hazardous situations that may result in minor or moderate injury. But what's most critically important is to understand this level of hierarchical risk priority that the standard associates and assigns to these words. Again, unfortunately, ANSI Z535 does not provide guidance towards specific physical location or equipment applications where a given hazard word may be appropriate. Rather, the standard only directs which hazard word should be used relevant to the level of hazard as determined by the user or poster of the sign. So it's really up to the utility to decide where danger should be used over warning, over caution, etc. And then notice is used to indicate information that's considered important but not hazard related. The safety alert symbol is always incorporated in the signal word panel with the hazard alert signal words danger, warning, and caution. The symbol is not used with notice, safety instruction, or safety equipment location signs. And the signal word header panel is to contain only the signal word and the safety alert symbol. It can't contain other words that should belong in the worded message, such as keep out. They belong down below the header. The next design element would be type style, justification, and size. The standard directs the preferred use of sans serif typeface, and so I've given you an example here of each. Sans serif means simply without embellishments, and so the reason it does that is it believes that it's easier to read and you can't confuse characters as easily. The standard directs the use of mixed case, where only the first letter of the first word in a sentence is capitalized because that's been demonstrated to be easier to read. And so that's hopefully apparent when you read the version on the left versus the version on the right. And then a single word or phrase, such as high voltage, can be set in all uppercase to provide emphasis. Left-aligned, ragged text alignment is specified because it aids in readability, forming a vertical alignment that allows the eye to more easily jump to the next line of text. So again, hopefully you can see the difference there, the example on the left versus the example on the right. A short one-line phrase may be centered for emphasis. And I want you to also note separation of the message content components, and I have a slide coming up that's going to talk to the effectiveness of that. For purposes of legibility, the standard provides guidelines to achieve proper line, word, and letter spacing when typesetting the word message. Again, I think it's pretty clear that the example on the left is easier to read than the example in the middle, where it's spaced out too much, or the example on the right, where the lettering and lines of text are too crowded. Allowable safe reading distance is relevant to text size. Safe viewing distance is that determined necessary for the reader to remain at a safe distance from the hazard while reading it and still be able to take appropriate evasive action in order to avoid it. So Z535 provides a chart for that, depicted here, of letter heights that are determined necessary to achieve a minimum safe viewing distance. But the standard doesn't identify what that safe viewing distance is in any specific application. Again, that's left to the posting utility to determine based on their knowledge and experience with the hazard, as well as best industry best or standard or best practice. The next design element's message content. The standard suggests providing and breaking the word message into three components. The first is an avoidance action. The example here would be keep out. The next is a hazard description. What is the hazard? In this example, it's high voltage. And then finally, a consequence statement. In this example, can shock, burn, or cause death. So what is going to be the consequence if the reader comes in contact with that hazard? However, the experiential knowledge of the intended audience and the physical barrier control of the hazard can be taken into account when drafting the word message or considering whether all of the content elements are necessary. So to give you an example, the interior components of a locked pad mount equipment cabinet might only need the energized exposed components identified with the safety message high voltage and nothing else, since only trained workers with an understanding of that hazard would have access and would be working on those components anyway. On the other hand, a hazard message on the outside of a cabinet intended to warn the general public should contain all three word message components, since that audience can obviously access that physical environment and they would not be expected to be knowledgeable of the hazards that it contains. The standard recommends writing in headline style using concise, succinct statements because it promotes faster comprehension and reaction time to the safety message. So again, hopefully you can see the difference between that on the left versus that on the right. And that means eliminating non-essential words, pronouns, articles, conjunctions, prepositional phrases, etc. Separation of the word message content using an outline format has also been demonstrated to enhance readability. So again, here are different examples on the left and on the right. And then the last design element I'd like to cover is pictogram symbols. Safety symbol pictograms are one of the more misunderstood and confusing design aspects of Z535, I think. Safety symbol pictograms aid in quick identification of the hazard, especially among speakers whose primary language is other than that which the written message is communicated in. Individual safety symbols should be designed wherever possible as elements of a consistent visual system. So therefore, the standard provides symbol creation guidelines. The standard encourages the use of effective safety symbol pictograms, and it provides human factor analysis testing guidelines for their development. ANSI, however, does not approve, recognize, list, or in any way endorse any specific symbol pictogram. The guidelines that it gives, I mentioned, include elements such as standardization of the depiction of the human figure, where to articulate that human figure. If there's bends in the elbow or in the legs, etc., it shows the articulation points. Application and design of the prohibited action circle / symbol, placement, color, surround shapes, etc. The standard specifies that the symbol pictogram must be compatible with the written message. Effective safety symbol pictograms employ three basic characteristics. The first is legibility, which is the viewer's ability to visually distinguish the key elements of a symbol. The second is simplicity, no unneeded detail or decoration. And then the third is comprehensibility, and that means the symbol is likely to be understood as intended, but equally as important, it's unlikely to provide confusing meaning that may lead to misunderstanding that could have possible negative consequences to the reader. Again, though, symbols should demonstrate simplicity, but representational symbols are preferred over abstract symbols. And hazard description symbols are preferred over hazard avoidance symbols. And certain special symbols, for example, you may be familiar with the biohazard or radioactive safety symbols. And so although they may be abstract, but because they're primarily used to communicate safety messages to experienced audiences, they're understood more through trained recognition. And so that's an exception to abstraction. And then regulations, such as those put forth by OSHA, appear to draft their own design. Oh, excuse me. So we're on to frequently asked questions. And so the first frequently asked question I put up here is that regulations, such as those put forth by OSHA, appear to draft their own design standards. So why does OSHA have headers that are different than ANSI Z535? And so you may be familiar, if you look at the headers on the left, those are the current ANSI Z535 headers. The ones on the right are often referred to as OSHA headers. And so let me explain that for just a minute. As I said back in an earlier slide, regulating agencies such as OSHA or standards such as the NESC don't try to reinvent the wheel by designing their own safety messages. And so the headers that you see on the right that are often confused as being OSHA are actually ANSI headers that were in use before 2002. And so with the 2002 revision of ANSI to the current time, the 2011 revision, those headers on the right have been made obsolete by the headers on the left. But OSHA has continued to accept the headers on the right because in the old OSHA regulations, they actually cited ANSI Z535 1968 standards where those headers were allowed to be used. However, in September of 2013, OSHA updated its rules for regulations requiring safety signs, labels, and tags to include the headers and the other design elements in the ANSI 2011 revision. But OSHA is also sensitive to incurring additional costs to employers, and so they do still accept both header designs with the idea that they understand eventually as signs and labels and tags wear out, these older headers are going to be phased out. And so OSHA is driving ultimately towards the updated ANSI headers and all the other ANSI design elements. The next frequently asked question, how big does my sign need to be for any given application? And so again, there aren't really any, there's nothing in ANSI and there's nothing in any regulations or codes that say, for instance, a sign on a substation enclosure needs to be a certain size, or a label or tag on a locked pad equipment enclosure, pad mount equipment enclosure needs to be any given size. What dictates the size is, if you think back to that slide I gave where text size affects the allowable reading distance, and so the utility needs to determine what is that minimum safe viewing distance, what's the minimum text size they need to use for that, and then depending on what the worded message content of their sign or label is, that's what's going to dictate the size of the sign or the label. And then the last frequently asked question we put up here, since danger represents the most serious level of hazard, can I simplify that decision of which header word to use and just use danger on everything, since it should cover all circumstances? And so again, I'm going to refer back to an earlier slide. I said that certain colors and certain header words occupy a hierarchical level of hazard. And so by using the most serious level of hazard, danger, the problem is that it dilutes the meaning. It dilutes the seriousness associated with that word, and the public gets conditioned eventually, if they see danger where there really isn't that big a danger, then they don't come to understand the level of seriousness associated with that hazard. And so that's why you don't want to use danger on everything. It's kind of like crying wolf. And so with that, I'm going to open it up to questions from our audience here today.
Thank you, Brandon. And really fast before we get into questions, I would like to announce that this week, we will be posting a new blog piece on Wednesday written by Brandon that answers the question, what are the most durable sign materials? So we will be sending out an email once it launches, so please look out for that. Now we will get into questions. I understand, though, that we are pretty much at that 30-minute point. So if you have to jump off the call and you do have a question, please take down Brandon's email and feel free to email him directly. But if you do have a few minutes, we will go over some questions that were posted. So starting with the first question, are there any other backgrounds besides black and white that I can use for my signs, like yellow, orange, etc.?
Okay, good question. But again, it goes directly back to one of our earlier slides where we talked about the use of color in the ANSI Z535 standard. And so the colors are reserved for the header word. And for the background where the word message is, it can be either black text on a white background or white text on a black background only. So you're not allowed to use any other color schemes for that for the word message panel area of the sign or label.
Okay. And I have signs that have all caps and center text, but use the ANSI Z535 danger header. Can I still use this sign? Am I still compliant?
And so that sounds like the kind of sign that would have fallen under, typically you would have seen that under the old ANSI Z535 revisions, where they didn't specify a more fully developed word message. And so although OSHA will allow you to leave up signs and labels that were posted prior to the 2011 revision, or until they wear out, you don't need to update those to the most current standard. Or if you have old stock inventory and you can validate or verify that that's old stock you had on your shelf before the newest revisions, you can go ahead and still use those signs. But it would be strongly recommended that as soon as those wear out, that you go to utilize the Z535 2011 standard that requires a more fully developed word message and left alignment, ragged right justification of text.
And for our last question that I see in here, can I substitute the hazard header colors, for example, using ANSI approved red behind caution or warning?
So the answer there is really simple. It's a point blank no. ANSI safety red is always associated with danger. ANSI safety orange is always associated only with warning, and ANSI safety yellow is always associated only with caution.
Okay, and I don't see any more questions that we have that have come in at this time. But like I said earlier, if you do think of a question a little bit later, please take down Brandon's information and email him directly. Thank you for joining us this morning. We hope you have a great week.
Thank you, everyone.